All right, so we're going to fill in our chart first. All right, so here we go. First, one sentence at a time. One sentence at a time. The total number of hours for production is 85. So the production total is 85. There are 40 hours for finishing. So the finishing total is 40. Pro boards require 1.5 production. Make sure you're getting them in the right spot. 1.5 production and 2 hours of finishing. Those are pro boards. Pro, 1.5 production, 2 finishing. And specialty boards require 1 hour of production and a half an hour for finishing. The profit on a pro is $50, and the profit on a specialty is $65. Now remember from our other examples, this last box here is left blank because the total profit is what we're going to try to figure out. We do not know that right now. If we knew that, we wouldn't be doing the problem. So that one's going to be empty because the total profit is what we're trying to figure out. All right, let's get some variables in here. I don't have any X's and Y's yet. Can we let X's be pro and Y be specialty? Is that okay with everybody? Because I got to write some equations, so I need to have some variables. So X is going to be the number of pro boards I make, and Y is going to be the number of specialty boards I make. All right, so give me an equation for this first row. The rows give you the equations. So what's this going to say? 2x plus 0.5y is less than or equal to 40. Because 40 is the maximum hours we have. All right, so 2x plus 0.5y is less than or equal to 40. I use 0.5, you could use 1/2 if you wanted. All right, now give me an equation for this row. 1.5x plus y is less than or equal to 85. Is that okay with everybody? The only reason we build the chart is because that's how we organize so that we can get our equations. Now, this is not going to be an equation because I don't have a number over here, right? Profit is what I'm trying to maximize. How do I calculate my profit? My profit will be 50x plus 65y. Now, I don't graph that one. I don't have enough information to graph it. Do you remember what I used this for? What do I do with that? So once I draw all this, I'm going to get a picture that has some points, big black points, and those get plugged in here, and the biggest one wins. Right? So here we go. Let's go. Wait, there's 2 more. What are the automatics here?
X is greater than 0.
And y is greater than 0. Yep, those are the automatics because obviously x and y have to be positive. Okay? All right, so now I'm going to graph it. And when I graph, I'm going to use my intercepts. Okay? And I'm not going to be freaked out because this one happens to have decimals in it. If I cover up the x, cover it up, ignore it, your equation says basically 1/2 y equals 40. If you cover up the x, 1/2 y equals 40. So to figure out what y is, aren't we going to multiply by 2? So y is
80.
multiply by 2. Wouldn't it be 80? 80? So that's a big number, so I think I'm going to count by tens. So here's 80, right here, 0, 80. So again, I cover up one letter. I started with X, doesn't matter. Cover up one letter and solve the equation that's left. Now, cover up the other letter and solve the equation that's left.
20.
So that one's 20, but I'm counting by tens, remember, because the numbers were too big. Now I'm going to connect those and shade underneath. Now, my shading is really making my board a mess, so I'm not going to actually shade, but you can on your paper. This is what's shaded, right? Less than means underneath. Okay, so right now I've got this triangle right here that's shaded in. All right, so now I'll pick a different color and I will redo exactly the same situation. Okay, so if I cover up X, there's no solving. If I cover up X, it just says Y is 85. So that would be like right here. And then, if I cover up Y, it says 1.5x equals 85. So I gotta divide by 85, or excuse me, by 1.5. So 85 divided by 1.5 is a little more than 56, like 56 and a half. Oh, this is weird. 30, 40, 56. So this out here, it's about 56.6, comma 0. And I'm going to connect those dots. Well, this is kind of a weird problem, but it's actually easier than our other ones. So even though it messes up my board, I'm going to go ahead and shade. So remember, we shaded underneath the red. And now I have another less than, so I'm shading underneath the green. Where is the overlap? Don't be confused. It is where it is. Where is the overlap? Isn't it just the original red triangle? So my corners are that point, and this point. Those are the corners. Now, in our other problems, your green one came through like this, and so we had a separate little region. That's not what happened here. The green one is actually on top of the red one, totally, which is fine. So what are my big black dots? 0, 80, 0, 0, and 20, 0. Those are the corners of the area that is red and green. All right, we're almost done. What do we need to do now? We have all of our corners.
Now you plug it into the profit.
So now we figure out, this is an X and a Y, figure out what the profit is for each of those points. So if X is 0 and Y is 80, that profit would be $5,200. X is 0, Y is 80. Now what if they're both 0? Then the profit is 0. Obviously, you don't make any skateboards, you don't make any money. 20 is X, and Y is 0, so that would be $1,000. So if you're the financial advisor for this guy, this company, what are you going to tell him to do?
Make 0 close and all.
Exactly. So the company should make, no pro boards and 80 specialty boards. for a total profit of $5,200. Now, that is a little bit unusual problem. That's not happened to us before, but is what it is. Anybody have a question about it before we start over again on our homework problem? That's it for our notes. All right, let's find the 7.5 homework. And we're going to do exactly the same thing. So notice how it's set up on the paper, homework paper. It's got all the stuff that you're going to have, and you're going to start filling stuff in. So while I'm getting this all set up, why don't you go ahead and see if you can fill in your chart down there with vitamin A and vitamin C and cost. We're doing a homework problem now. So if you don't have your paper, just pull it up in Schoology. You can do it that way. Alright, so here we go. Jameson needs 4 milligrams of vitamin A. Where am I going to put the 4? Daily need for vitamin A. And 125 milligrams of C. Everybody okay with those two placements? Brand X supplies 2 milligrams of A and 25 milligrams of C. This is brand X. And Y supplies 1 milligram of A and 50 milligrams of C. How many pills of each kind should he take to meet the minimum requirement in the most economical way possible? Brand X costs 6 cents and brand Y costs 8 cents. Now, does anyone have a question about why a number got put in the spot that it got put? So on test day, points right there. Right, even if you can't do anything else, you get points for that.
I thought it'd be like 0.06.
It can be, to do whatever you want. In my problem, if I get 102, that's gonna mean $1.02. You're gonna physically get 1.02. So whatever is easiest for you, Gabe. All right? Yeah. I just have to remember that my unit is going to be cents now. Okay? All right. Now, having set up the chart, you should be able to write the constraints, because the constraints are the equations that come from these two rows of the chart. Any row that has numbers all the way across is going to give you an equation. So what's the equation for the top row here, the vitamin A row? 2x plus y
Is less than 4.
actually is greater than or equal to 4.
You need at
Why?
least-
Read the problem.
Cause you need to take a
You
lead.
need at least 4 this time. Did you catch that?
No.
At least 4. That's your minimum daily requirement. So if you don't get 4, you're going to be deficient. Get sick or something. Yeah, I don't know what vitamin A does for you, but you need it.
Wait, does it, cause it says needs 4?
Huh?
Is it, not because it needs 4?
Yes, you need at least 4. At least 4. Now, what difference is that gonna make in my picture?
Minimum?
I'm shading above instead of below, right? It isn't gonna impact drawing the equation, or, drawing the line, but I will shade above it now. Same thing's gonna happen with vitamin C. That equation is going to be plus 50y is greater than or equal to 125. These are the minimum daily requirements, so you gotta have at least that much. So that much or more. And then of course, we got our standbys, right? Easiest points ever, stupidest points to miss, put them in there. Now, in this case, you gotta be able to read, you gotta read it, the problem. It says we wanna be the most economical. What does that mean? Cheapest. So we don't wanna maximize this time, we want to minimize our cost, don't we? So when we get all of our points, we won't be looking for the highest value, we'll be looking for the lowest value this time. Remember, in life, you want to maximize profit, you want to minimize cost, right? So if you're doing a cost, you want the minimum 1. If you're doing a profit, you want the maximum 1. Doesn't that make sense? Okay. All right, so what's my cost? My cost is going to be 6x plus 8y. And as Gabe pointed out, that's going to be in cents. So if I get 28, that's 28 cents. All right, so here we go, let's draw on. So I'll do this one in red. So covering up one letter at a time, if I cover up X, it looks like Y is 4. This time I can do that in my head. Sometimes I have to write it down and work it out. If I cover up Y, X is 2. And this time, remember, it's a greater than, so we're actually shading up here. All that shaded, we're shading above the line. So if he takes pills down here, he's not gonna get enough vitamin A. Do you understand that? To get enough vitamin A, he's gotta take pills that are out here. All right, next, this one has bigger numbers, but it's okay. If I cover up X, it says 50y equals 125. So 125 divided by 50 is 2.5. So that was y was 2.5. And if I cover up y, 25x equals 125, so x is 5. Now where is that one shaded? Above also? So if I shade above the red and above the green, would you agree that I am shading all of this that area right there. All of this right here is being shaded because it is above the green and above the red and in quadrant 1. Okay? All right, so I've got 3 dots. These are the corner points of the shading. And my 3 dots are 0, 4, 5, 0, and then that one. Now, in the last problem we didn't have to worry about that because our lines didn't cross each other, but they are crossing each other this time. So we're going to have to find that point. Okay, these are big problems. How do we find that point? I'll give you a hint. You did it on your quiz. Elimination or substitution. So our 2 equations are 2x plus y equals 4 and 25x plus 50y equals 125. Now, before I do that, does anyone have a question about how I got the red line or the green line? Everybody's got the red line and the green line. Everybody sees that the shape of the overlap part, the green-red overlap, has a corner here, and a corner here. This is the x-axis, this is the y-axis, and that's what these two take care of. So they create those corners. All right, so we're all good on the picture. Now I'm working on this point, which is where red and green cross. Here are the 2 equations. Now, you can do whatever you want. You know I'm going to eliminate because that's what I do, but you can substitute. If that's your favorite, you can absolutely substitute. You can get this y by itself and substitute.
Would you multiply a column like -50?
I would. That's what I would do. I would multiply the top equation by -50. So I have -100x minus 50y equals -200. And then I still have 25x plus 50y equals 125.
Why don't you just substitute it? It's like easier when it's like that.
You think substitution's easier?
Why?
You know what? That's what's so marvelous about math. Easy is a relative term. It's not easier for me, but if it's easier for you, do it. Absolutely, do it.
I'm more of an elimination type of guy.
I am too. So I end up with -75x equal to -75, so x equals 1.
Then you just put that
Now, those of you that are substituting, you're going to get exactly the same answer. It's not going to matter how you do the problem. So I got x equals 1. So then my y value, I'm going to plug it back in, one of my equations, and again, doesn't matter, plug it in wherever you want. If I plug in 1 for x, it looks like
2.
y is 2. So that corner right there is the point 1, 2. So now you have your 3 corner points. This time there's 3. There was 3 in our other example today, but our ones the other day we had 4. It just depends what shape you get. Write down every corner point. Then what? We're almost done. What is the last math we have to do? We have to take each of those points and see how much it costs. So this would tell me to take no x's and 4 y's. That's what this means. I'm sitting here with my handful of pills. No x's, 4 y's. Well, if I don't buy any x's, but I take 4 y's, that's going to cost me 32 cents. What if I did 5 x's and no y's? that would be 30 cents. What if I did 1x and 2y's? So 1x and 2y's, that would be 22 cents. Now remember, you gotta pay attention, we're trying to be economical, so we are minimizing the cost. So the answer is gonna be the lowest one, right? Minimizing. So the answer to the question is what? He should take, what are you gonna write?
You should take one, X, what is that? One vitamin,
He should take 1 X pill and 2 Y pills for a cost of, 22 cents. Does that make sense to everybody? Okay, well, you've got your practice tests. We're gonna go ahead and get started on those. And there's one of these on every practice test, so we'll practice 3 more times. So let's get those out. Well, we got 3 practice tests. So we will, so it'll be, we'll have a couple, probably depending on how fast you get through here, we'll have at least 2 more days before we take a test, 2 more class days. But it probably will be 3 more class days.
This board,
Yes.
do you want us to still turn this in?
Let's be on our code. Did everybody write that down? Everybody present wrote that problem down? Courtney, did you do that homework problem?
Yes.
Okay, so everybody did it. So I'll just record it for everybody who's present. Anybody who's absent has to turn it in, but the present people can.
wait, so we do get, we don't get,
You do not have to turn it in. I will just record it in the grade book. I mean, we just did it, so there's no point in you turning it in.
Let's go.
I just have to remember to put that in there, though. That was my job.
I'll be shooting.
All right, so we got our practice tests out. Nate's whipping through the pages. He said, oh my gosh, this packet is huge.
I think we can do it in 15.
I think we probably can't, but I appreciate your optimism. All right, so the reason it's so big is there's a bunch of stuff spread out. Plus, that problem takes a whole page, and the calculator problem I left a whole page for. All right, so here it's not so bad, but I want you to pay attention to page 1. Page 1, let's get this page done, all right? Page 1 says, solve the systems, but specifically tells you how you have to do it. Leo?
Question, on the test, will we have to do one with substitution, or
Yep.
can we just do how?
The test's gonna look exactly like this, right? Just like always. So, yep, you're gonna have to do it exactly how it tells you. Now, I am gonna be nice about it. Like this first problem, I told you have to use substitution. Well, like you just said a minute ago, Farrell, this one's gonna be easy to substitute with, right? Because you can get x by itself. So I'm not gonna give you anything wild and wacky, but yes, you are gonna have to do substitution. So gotta get one of the letters by itself. I don't care which one. That seems to be the easiest one for me. Maybe not for you. And then we're gonna take that and plug it in right here, right? So we'll have 2 times 7 minus 2y minus y equals 4. Okay, so here we go. 14 minus 4y minus y equals 4. So 14 minus 5y equals 4. Please be careful with your negatives now, guys. We're going to subtract 14. But that's going to leave us with negative 5y equal to negative 10. Don't lose the negatives. So y is 2. Then what do? We don't stop, do we? What do we do now? Plug it back in, and you can plug it in wherever you want. You can plug it in one of these, you can plug it in here. I think it's easiest, me personally, to plug in here, but you can plug it in wherever you want. If y is 2, what did you get for x? 3? And then we write our answer, 3 comma 2. We write our answer as a point, just like we did on our graphs we just did. Those two lines are intersecting at that point. Problem finished. Anybody have a question about that one?
Wait, do you plug in the two into like the rewritten problem?
You plug it wherever you want. Makes no difference.
So I'm just confused if you'd plug it in like the x equals 7.
You can put it there, you can put it there, you can put it there. It doesn't make a single bit of difference. Put it wherever you want to. Just make sure you're putting it in for y, because that was a y value. All right, now we're going to eliminate. Now, if we are eliminating, then we have to make a letter, either the x's or the y's, cancel out. So what will make them cancel out? Nothing cancels right now. What will I need to do to make something cancel? The bottom by 3 will make them cancel, because that would make my 3y and negative 3y cancel out. Remember, if you're doing elimination, Nathan, you awake, sweetheart?
Mm-hmm.
Okay. What are you doing?
Yeah, so
Okay, well, let's turn around, face forward, and let's really get focused so we can do really well on this test. So remember, you got to have one positive and one negative. That's the whole key. That's how they eliminate. So 11x equals negative 11, and x equals negative 1. And then just like before, plug it in wherever you want, anywhere. So if I put it in my top equation, I'll have 2 times negative 1 plus 3y equals 4. So negative 2 plus 3y equals 4. 3y equals 6, and y equals 2. So my answer is negative 1 comma 2. Remember, when you write your answer, it has to be x comma y. All right, now we've got Cramer's rule. So these two are kind of old news for you. You've been doing these for a long, long time. Back when you had Mrs. Field and Mrs. Ludington, you were doing this. This is all review. Now, we've got a newer method. Cramer's rule. All right, so who remembers how Cramer's rule works?
You do like the straight line.
Okay, those are called determinants. I need to make a determinant.
And then it's like the 2 and the negative 4 in the first, and then the 3 and the 2 in the other.
Okay, so what she just did was make a determinant out of the coefficients. So 2, 3 are the x's, and I went ahead and labeled them. Negative 4, 2 are the y's. Now I'm going to evaluate that. So I do my downs, which are 4. my ups, which are negative 12, and then I subtract them, so I get 16. 4 minus negative 12. Now, that number is the denominator of your x and y. Remember, our job is just like it was with substitution and elimination. We're finding a point. So the x and the y I come up with are going to be fractions, and the denominator is going to be 16. Now, who remembers how I find the numerators?
You take the equals, the numbers you have in this row,
Right here.
and you plug it in for the x row and then the y.
Exactly. So we cut out this column, this guy right here. Cut him out and paste them on top of the x's. So you're going to have a 1 and a negative 2, and then you'll still have your negative 4 and 2. So if I am finding the x numerator, I'm going to cut this out and paste it right there. And then if I'm finding the y numerator, I'm going to cut it out and paste it here. So 2, 3, and then my 1, negative 2. All right, now take a look at that and make sure you can structure that.
Do you have to put the 2, 3 first?
Yes, because for here you mean? Yep. When you cut this out, you're pasting it on top of the letter. So since I'm doing y, it gets pasted here. So I have the 2 and the 3 not moved, and then the 1, negative 2. Fills your hand up? All right, so then I do just what I did here. So I multiply down is 2. Watch it. Up is 8. And then I subtract. So that numerator is negative 6. 2 minus 8. And then this one is negative 4. 3, I'm subtracting negative 4 minus 3, so that'll be negative 7. So that numerator is negative 7. For your final answer, you need to simplify anything that will simplify. So this actually does reduce. So x will be negative 3/8, and y doesn't, so it just stays negative 7/16. That's a horrible looking answer, but we don't have to do anything with it except write it down, so it's not a big deal. All right, page 1 done. Everybody got substitution, elimination, Cramer's rule. All right, we'll do a little bit on this next page. All right, so this whole page, all right, so I'm keeping track of what this test is going to look like. One page is going to be substitution, elimination, Cramer's rule, solve the system. Then it looks like we have a whole page of matrix operations. Well, you just took a quiz over this, so hopefully you're pretty good at this. What is 2A? What do I do for 2? This is part 4, number A, but the question is 2A. What does that mean? What do I do? Everything in matrix 2, or everything in matrix A by 2. So it's simply going to be 2, 4, 6 on the top, negative 2, 2, 0 in the middle, and 0, 6, 2 on the bottom. Easy. Easy, right? Got it. B says B minus C. So matrix B minus matrix C. Now remember, sometimes that's not doable. Is this one doable? Can I actually subtract here? Yes, because they're the same size matrix. So when I subtract, I just do it entry by entry. So I'll take I'll circle them in green. These guys are in the same spot, subtract them. So 1 minus -1, 2. -1 minus 1, -2. 2 minus 0, and 3 minus 2. Done. Anybody have a question about any of those numbers? Keep track of your negatives. If you need to write them down, write them down. So like for that first one, it's 1 minus -1. If it helps you to write it down, write it down. All right, what about C? A plus B. You can't do it. So you either write can't do, impossible, the empty set symbol, something to indicate that the problem isn't doable. And why isn't it? They're not the same dimensions. This is an addition problem. It would be really easy to do, but you can't because the matrices are not the same size. So C is no answer. All right? We will do letter D, and then we will be finished. So here we go, letter D. Last problem of the day. Now, I'm going to go ahead and write this down, D times A, and then I'm hoping it's possible, because I'm wasting a bunch of time if it's not. Is this a doable problem? Now, this is multiplication. Matrix D comes first, and then matrix A. Is this a doable problem? Well, what are the dimensions here? 2 by 3. And 3 by 3. So is it multipliable? Yep. And the answer will be another 2 by 3. So to get this spot right here, I'm going to take my first row. I always do rows of the first, columns of the second. So I'll multiply -2, 1, 4, that's row 1, times 1, -1, 0, that's column 1. Multiply each pair and add them up, so that's -2, -1, and 0. So that's a -3. Everybody okay with that? -3? So now we're going to do the same thing, but we're going to use the first row, which is -2, 1, 4, times the second column, because now I'm over here in the second column. So 2, 1, 3. So -4 plus 1 plus 12, what is that? 9? Anybody have a question so far? All right, let's see if you can fill in the rest of them. You're gonna just keep doing the same thing. Row 1, column 3. And then you'll move down to row 2 and do each of the columns. So you go ahead and let's see if we can match. Yeah, definitely possible I made a mistake. Everybody matches? Everybody's good on that? All right, let's make a note, that's where we stopped, and we will pick up there.
I'll see you later.
Um,
I'll see you later, Karen. You too, kids. Little rivalry going on right
and
now.
good luck to our